Hello and welcome back to another episode of Math with Sohn. Today we're going to be doing some domain and range on some absolute value functions. So absolute value functions are one of my favorite ones because they introduce us to something called vertex form. Now vertex form by definition is y equals a x minus h plus k. But I like thinking of it as change the sign, keep the sign. So you change the sign here and you keep the sign on the outside. And that will be your vertex. And then the number in front, if there is quote unquote your slope for vertex form or function transformations. It is if and only if the graph is an absolute value. So for today, it will be kind of the slope on at least half the graph. So if we change the sign, the x plus 1 is going to turn into a negative 1, and keep the sign, that negative 3 will stay a negative 3. And that is, in many circumstances, what you would call the vertex of the graph. So we're going to plot the point at negative 1, negative 3, 1, 2, 3. And in this particular graph, the vertex is negative 1, negative 3, and the slope is a positive 1. So from here, I'm going to go up 1 over 1, and up 1 over 1, and I'm going to graph that. Now you notice I only graphed this right side. For an absolute value, it is going to mirror image from the vertex on the other side, and it's going to go the other direction, up 1 over 1, up 1 over 1, and it's going to bounce backwards and be reflected, just like I drew. The domain and the range, the domain for each and every one of these is going to be going to the left and to the right forever. So it's going to be all real numbers or from negative infinity to positive infinity. The range is going up from the y value of this vertex, which is at negative 3. So the range is including negative 3 and going up to infinity. You could also say y is greater than or equal to negative 3. Both of those are effective. All right. Moving right along, that was the longest example. The other ones are going to go pretty quickly, I would imagine. The vertex here is 0, positive 2, because we have nothing to change, and the 2 is the keep the sign, and the keep the sign is on the outside. So we got 0, positive 2. The slope this time is 3. They actually call the slope the vertical stretch or dilation. So in this case, it was stretched up 3 over by 1, so it is getting skinnier. We're going to go up by 1, 2, 3, and over by 1, and you'll see what I'm saying by that. Whenever we look at this graph looks like it's a very skinny-looking graph, and it is going to be going up 3 over by 1, and there we have it. So it's a little skinnier than the previous problem. The domain is still all real numbers, negative infinity to positive infinity. The range is y is greater than or equal to 2. You could also say including the 2 and going up towards positive infinity. So that's why it has the bracket and then the parentheses. All right. Moving right along, on this one, we have a slope of negative 1/2. Your vertex, change the sign, keep the sign would make that negative 1, positive 4. So negative 1 up to 1, 2, 3, positive 4. And then from here, we go down 1 over by 2 because that's the slope. So we go down 1 right by 2. Mirror image it, down 1 other direction by 2. There is our V. Absolute value graphs look like a V. Domain is still negative infinity, positive infinity. The range would be going from the depths of the earth, negative infinity, up until you get to 4. Or you could say y is less than or equal to positive 4. That's a bracket. It's an ugly looking bracket. All right, next one, change the sign. Negative 2 changes to positive 2. Keep the sign, 2, 3. That is our vertex. Let's plot it at 2, up by 3, 1, 2, 3. And from this one, we have a slope of negative 1. So we go down 1 over by 1, down 1 over by 1. Mirror image it on the other side. There is our graph. Beautiful. Domain, negative infinity to positive infinity. Range is from the depths of the earth, negative infinity, up until the 3. All right. So now I have two unique problems. This first unique problem, if we change the sign here, this is still inside the absolute value bars. That's where we change. We get 3. You may think that there's nothing to keep. However, this 2, via the commutative property, I believe, can be rewritten over here. So there's no difference in that 2 being written in front or over here. So this is really 3, 2 for that vertex. So right by 3, 1, 2, 3, up by 2, bing, bang. Our slope is positive 1 over 4. So we go up by 1, right by 1, 2, 3, 4. And then mirror image it up by 1, over by 1, 2, 3, 4. And this would be called a vertical dilation because it got bigger. Okay, so it wasn't stretched vertically, it was dilated vertically. And we have a domain, still negative infinity to positive infinity. A range, it is going up from the positive 2. This is at 3, 2. So it's going up from 2 to infinity. You could also say, or you could say y is greater than or equal to 2. All right. This next one, this one is the one problem. If you have anything else inside of the absolute value bar, you can't just change the sign of the 4, okay? Technically, this 2 is stretching it horizontally. It doesn't really appear that way, but it is technically stretching it horizontally because every x value is doubled. So when you have 2 things in here, instead of changing the sign, this is what I want you to do. I want you to take the 2x plus 4, and I want you to set it equal to 0, okay? Whatever you get from that, it will have changed the sign because look at the first thing we're doing. We're subtracting the 4. We're subtracting the 4 from both sides. You get 2x equals negative 4, which means x value of the vertex when we divide by 2 is negative 2. Okay? So we have a x value of negative 2. There was no keep the sign, so it's negative 2, 0. All right? This would have a slope of 2 over 2. Let's see if it actually does. Or excuse me, 1 over 1. Let's see if it actually does. So let's plug in a few values and see what's going on. If we plug in the value negative 2, 2 times negative 2 plus 4, you get 0. Okay, so that makes sense. What about if we plug in the number, one number to the left or to the right of this, which would be at negative 1. If we plug in one value to the right at negative 1, are we going to go up by 2 or are we just going to go up by 1? Let's see. We do negative 2 times negative 1 plus 4. That ends up being negative 2 plus 4 ends up being positive 2. Okay, so when we plugged in negative 1, we got an answer of positive 2. So we are at negative 1, positive 2, which tells us something that this positive 2 is the slope. And it would be mirror imaged on the other side. If we want to double check it, what would happen if we plugged in the number negative 3? Negative 3 times 2 plus 4 ends up being negative 2, but remember there's absolute value bars, so it makes it positive 2 as well, which is why we have a point at negative 3, 2 and a point at negative 1, 2. So both of them are mirror imaged and right there. All right. Last one, write an equation for the absolute value function provided by the graph. Here, you just need to identify what is the vertex. So in this case, the vertex is at 1, 2, 3, 0. And the slope is down 1 over by 2. So the slope, write it over here, the slope is negative 1 over 2. So we have y equals negative 1 over 2, absolute value bars. We have to change the sign of the x value. So that positive 3 would be a negative 3 and keep the sign of 0. Make sure when you change keep it that you get 3, 0. Sometimes these mix everybody up. So we got a slope of negative 1/2. We change the sign of negative 3. We get positive 3. We keep the sign of 0. We get 0. We're good to go. You could also rewrite it as y equals negative 1/2 x plus, minus 3 without the plus 0. You don't need to write the plus 0. Last one for the day. We got a vertex of 1, 2, 3, 4, comma, negative 2. So that vertex is 4, comma, negative 2. The slope is up 1 over 1. So we change the sign of the 4. 4 will become negative 4. We keep the sign of the negative 2. So it'd be x minus 4 in absolute value bars. Make sure they're big so they don't look like a 1, minus 2. And again, you don't need to write the 1 over 1 for the slope, so you could just write x minus 4 minus 2. That's going to do it for this one. Until next time, I will see y'all later. See ya.